Greetings everyone. Today we're going to explore imaginary and complex numbers. We do have a foldable for this video, so make sure you have access to that or jot this down in your notebook. All right, let's think to some quadratic solving. For example, like this. My first thought is I have a binomial, I have perfect squares, but unfortunately I don't have a difference. And so I try to just solve it by isolating x. If I try that, I would subtract the 9 over. The opposite of squaring is square rooting. But if I try to plug that into my calculator, I know a 3 is involved, but I won't get a solution because we've always said we cannot square root negatives. And so since we can't square root negatives, Descartes developed a plan. He invented a new number system and a new type of numbers called imaginary numbers. This happened in the 1600s. And so we're going to use that 3, but as with the first letter in the word imaginary numbers, we're going to use the letter I to denote that square root of a negative. So in our notes, let's start with what is an imaginary number. So the I, we try to write it, I tend to write it cursive just so we're for sure that it is an I. But an imaginary number comes from square rooting a negative value. And so one of the simple operations we can do is if we square it, we would arrive at -1. Well, think about that, right? If I was to square one side, I'd have to square both sides. So I'd get I squared. And when you square root a radical, a square root, they're inverse operations, so they cancel out and we're left with -1. Okay? So what we need to know right now is that I comes from the square root of -1. And if I square both sides, I end up with just -1. All right, so let's go over how do I even use this I? How do I write this I? So let's start off with this. The first thing you want to think of is instead of a negative under the radical, we bring out and make it an imaginary value. So we're going to have that I out front. Once I've done that, then I can deal with the radicand as it is. And so square root of 25 is 5. Now, similar to other variables, I mean, this isn't a variable, it's a number system. But similarly, you want to write it so that the number is in front of the letter, right? So we would just say 5i. Let's try another one, square root of -6. So the first thing I would do is I would take that I out, which leaves me with square root of 6. And in this case, square root of 6 doesn't simplify, it doesn't reduce, it's not a perfect square, so we're just going to leave it like that. All right, let's try square root of 40. So first thing I'm going to do here is I'm going to take out the I. Now 40 is not a perfect square, but it does break down. Remember, perfect squares? Let's see, 4 and 10. The square root of 4 is 2. But we want to write the number first. So here's where it gets kind of weird. You're going to have the integer, then I, then the radical. Now, you don't have to show every little step here, right? My hope is that we can jump a bunch of these steps to the simplified version. Let's try another one. We're going to include operations in this process. So when things are next to each other, it means multiply, right? So I've got 5 times. I'm going to take an I out of the square root. Take an I to represent the negative under the square root. Let's break down the square root of 48. Think about that. What's a perfect square that fits in? 4 does, but something bigger does. 16. 16 fits into 48 3 times. Well, 16, the square root of 16 is 4. And 4 times 5 times I is 20i. Square root of 3. So again, don't need to show every little step. My hope is that you understand that the values are being multiplied and that you know what order to write them in. Let's try another one. The first thing I'm going to do is take out an I to represent the square root under the radical. 10 doesn't divide by 3. There's no perfect square going on here. So we actually have to separate this square root into its own numerator and denominator. The reason why we need to do this is we need to rationalize the denominator. So what that means is I can't leave anything irrational in a denominator, right? Like we can't have 0 in a denominator. We can't have pi in a denominator. We can't have a square root in the denominator. So to get rid of that, we multiply the numerator and the denominator by the denominator. Okay, so that means radicand times radicand gets me to square root of 30. Square root of 3 times square root of 3 is square root of 9, which is just 3, right? It's a perfect square. That's why we do that, because we end up with an integer in the denominator. Now double check, 30 does not break down, but I want to make sure. So this is my simplified radical. All right, so let's talk about a newer vocab word, complex numbers. So complex numbers have a real part and an imaginary part. For example, if I take a look at these problems, I have a real piece and I have an imaginary piece. Now, the benefit to these operations is we start off treating the I like any other variable, meaning we're just going to combine like terms. I've got a 7, and if I combine 2i subtract 6i, a negative 4i. So we treat it the same way to start. What's most important though, the real part always comes before the imaginary part if you have two terms, all right? So we want to keep real first, then imaginary. Let's take a look at this next example. This looks like a binomial times a binomial. So we're going to treat it the same way as we would any variable to start, and we are going to FOIL. So first would be 12i. Outer, or if you're doing double distribution, it might be a little different, would be, 15i squared. Inner would be positive 24. Last would be negative 30i. So the first thing I notice is I can combine those like terms, and we're going to have a negative 18i. I'm going to bring down the 24, but we need to talk about this. Do you remember at the beginning of the notes we talked about I squared? So I is the square root of negative 1. And if I squared both sides, I got negative 1. So that I squared, we're going to change that. What this becomes, it's a negative 15, but instead of I squared, we're going to substitute it with a negative 1. Now, your calculator, if you ever forget, you guys, has an I key, so maybe try that out. If you plug in I to the second power in your calculator, it'll tell you it's negative 1. Now what this does algebraically is creates another step for me. Negative 15 times negative 1 is positive 15. And then I can combine these like terms, right? And I arrive at 39, and I still have this 18i. Again, I care that the real value is first, followed by the imaginary value. Now, typically, we should only have those two pieces in the end, or possibly less, but no more. Okay, so let's take a look at some more. Let's say we end up multiplying and we arrive to I to the third or I to the fourth. We have to talk about, well, if I squared is something different, what are those values? So what's anything to the 0 power? Let's talk about that. Any value in the world to the 0 power is 1. That's still true. Okay. I to the first. Well, anything to the first power is itself, so that's nothing special. I squared, we just talked about that. I squared, if I square the square root of negative 1, we arrive at negative 1. Okay. Let's talk about I to the third. I to the third. Think about how I get to I to the third. You don't have to write this down, but let's just think about it. I to the first times I squared would get me I to the third, right? So if I take I and I times it by negative 1, I would get negative 1i. So I can get to higher exponents by dealing with these values. If I multiply those, it's negative I. Well, let's talk about the fourth. If I wanted the fourth, again, you don't have to jot this down, but that would be like saying I squared times I squared. That would give me to I to the fourth. Well, I squared is negative 1 times negative 1 is 1. So I to the fourth is 1. Okay? So notice, no matter the exponent, we arrive at some form of 1 or some form of I. Now let's take a look at the pattern. I, negative 1, negative I, 1. It repeats itself. I, negative 1, negative I, 1. Those of you that are good at memorizing, you're going to be able to memorize that pattern pretty quick and just know. You do have your calculator to help you with this process, okay? But we're going to need a little more help with this when my exponents are bigger. So let's jot this down in our notes. When you have, let's say, I to the 57th, right? I need to do some work, and I don't want to count out the pattern all the way to 57, all right? So to simplify this and make this process faster, to simplify the powers of I, you divide the exponent by 4. If the exponent, when divided by 4, has a 0 remainder, then that's like saying I to the 0, which is 1. If you take a number, divide by 4, and you have a remainder of 1, then that's like I to the first, which is I. If you divide the exponent and you have leftover of 2, then that would be like I squared, which is negative 1. If you divide and you have a remainder of 3, then that's like I to the third, which is negative 1. So you really only have to remember that 4-step pattern. So let's put this into practice, right? If I'm talking about I to the 5th, all right, here's how you can think it through. There's different ways to think it through, but I'm thinking 5 divided by 4. It fits in once with a 1 remainder. So a 1 remainder means I to the 1st. Let's try another one, 23. Okay, how many times does 4 fit into 23? Well, I can get to 20, right? And then after 20, I'd have a 3 remainder. So a 3 remainder is like saying I to the third. Well, I to the third is negative I. Let's try another one. 56. All right, 56. And I want to divide by 4. So when I divide 56 by 4, I have a remainder of 0, meaning it fits in perfectly, right? If it fits in perfectly, it's 1. So all of this becomes 1. But I have a factor out front, so my final answer is actually negative 3. So here's again, this is new. My first suggestion is to work on memorizing this. If you're not a good memorizer, you're going to work with the pattern. Anything to the 0 power is 1. Anything to the first power is itself. You're going to maybe want to you might want to write it out every time. And I always remember the first 3, you guys, because that means the next one is the pattern that's missing, which is a negative I. All right, let's take a look at a couple more examples. These aren't in your notes, but I just want to provide some more options since this is really new. So this I to the 6th, if I divide 6 by 4, it fits in once with a remainder of 2 units. So remember, a remainder of 2 means I to the 2nd, which is the same as saying negative 1. I've got to divide by 7, so I'm just going to leave it. My answer, or my simplified piece, is negative 1/7. Let's take a look at the next one. I to the 21st. So 21 divided by 4, it fits in 5 times with a remainder of 1. Well, a remainder of 1 means I to the 1st, which is just I. So I to the 21st becomes just I. And that 2 is hanging out front as a factor, so it stays out front as a factor. 131. So when you get really large numbers, think about that. I want to take 131 and I want to divide it by 4. So it fits in 32 times. If I take 4 times 32, that's 128. That means I have a remainder of 3. Remainder of 3. So you got to find out how you can figure that out. There's different ways to think it through. If I have a remainder of 3, that's like saying I to the third. So I to the third. I to the third is negative I. So all of this just became negative I, and it already had a negative out front. So a negative times a negative is a positive I. Careful with those double negatives, right? Maybe it would help if you wrote it as negative 1 times I to the 131st. All right, so multiplying, adding, and subtracting, as with variables, is pretty straightforward with the operations. But when it comes to dividing, we've got a lot of steps. So if you would please pause the video here to jot down these steps and press play again when you're ready. All right, let's work our way through these steps. So to divide complex numbers, it's kind of like rationalizing a denominator, right? You can't have something crazy in the denominator, so we have to do something about that. So we're going to multiply the numerator and the denominator by the conjugate. That's a new vocab word. Okay? To find the conjugate of a complex number, you're going to change the sign between the two terms. So let me give you an example. 3 plus I would change to 3 minus I. Just the middle number. Your goal here, just a heads up, is difference of squares. We're trying to get middle terms that cancel. Let me give you another example. If I have 57 minus 37i, the conjugate would be 57 plus 37i. You're just changing the middle sign. Okay, once you've done that, you're going to multiply top and bottom, numerator and denominator, by that conjugate. Okay. Step 3, you're going to simplify, right? So you're going to multiply it out. You might have to FOIL, distribute, triple distribute. And then once you've simplified, take care of the higher exponents of I. Combine like terms, simplify, break things down. Your goal in the end is to write your answer in the correct form with the real part followed by the imaginary part. All right, let's put these steps to work. Here is my first example. Step 1, we want to find the conjugate. Okay, the conjugate of this denominator is 4 minus I. Step 2, we're going to multiply the numerator and the denominator by the conjugate. Now keep in mind this is treated like a binomial, so I'm going to put parentheses around it to help remind me what I'm doing here. We can now multiply. I'm going to distribute the 3. I have a 12 minus 3i as my new numerator. My denominator, 2 terms times 2 terms, I need to FOIL. First, outer, inner, last. Look at what happened. We just created an outer and an inner that will cancel. That's the whole point. That's the whole reason why we use a conjugate, because we just eliminated the I to the first terms. All right, let's simplify a little more. Let's talk about this I squared. Remember, I squared equals -1. So this right here is going to become -1. Let me rewrite this denominator. I now have 16 subtract. Use the same color. I'm going to try to color match. 16 subtract -1. So my new denominator is 17. Now I'm going to bring over that numerator. It's okay to have an imaginary in the numerator. That's fine. We just don't want anything crazy in the denominator. Okay. Now, the last thing, because we want it in true form, is we're going to separate out that denominator. What I mean by that is we're going to have 12/17 subtract 3/17 I. Do you see how that's in the form of a plus bi? Our a is 12/17, our b is 3/17, and we have an I. All right, I'm going to do one more example. I know this isn't in your notes, but I wanted to provide another example if it's helpful. All right, this one's a little more complex because I have two terms in the numerator as well. So step one, I want to identify the conjugate of the denominator. The conjugate of the denominator is 3 minus 2i. So my first goal is I'm going to multiply the numerator and the denominator by the conjugate. So you see how this is a little more work? We're going to have to FOIL the numerator and the denominator. That's okay. We've been FOILing for a long time, so let's keep it going. So first, 15. Outer, negative 10i. Inner, negative 6i. Last, positive 4i squared. Let's take care of the denominator. First, 9. Outer, negative 6i. Inner, positive 6i. Last, negative 4i squared. All right, let's work on simplifying. Look at that denominator. Positive 6i, negative 6i goes away. I also want to acknowledge that I squared is the same as negative 1. Okay, let's simplify again, another step. All right, I'm going to bring down my 15. I have like terms here. That would be a negative 16i. Positive 4 times negative 1 is negative 4. In the denominator, I've got a 9. Negative 4 times negative 1 becomes positive 4. So be careful. Those negative ones, it's not difficult, but you got to watch your signs. All right, let's simplify that. Denominator becomes 13. My numerator becomes 11 minus 16i. And we want to write it in true form. So 11/13 subtract 16/13 I. See how it looks like that a plus bi form? So not more difficult when there's a binomial. You just got to acknowledge that you're going to have to FOIL twice. Alrighty, thanks for bearing with me. I know this is a long video because this idea of I is so new. We haven't worked with this before. And whatever you need to do to remember this pattern, you need to come up with a way to remember it. You also need to work on understanding that we need to divide by 4 and use the remainder to make decisions about what our value is. As always, take a look at what your task is on Google Classroom. Let me know if you have any questions. Check out PowerSchool, and until next time, have a good one.